So yesterday together we made this box and whisker plot. We found our 5 points here and drew a box around the first quartile and third quartile points. So I wanted to look at a little bit more how kind of the data is spread in a box or box and whisker plot. This center line is the median. Median sounds a lot like the word middle, because the median is the middle of the data. So the median splits all of my data into two halves. 50% of the data is on the right, 50% of the data is on the left. Okay, now 50% of the data is on the left. Quartile 1, this point here, that is the median of the lower half. So this point here splits 50% of my data into two more halves. The whisker of my box and whisker plot holding 25% of the data, and then this first section of my box holding 25% of the data. Okay, so the whisker is a quarter or 25% of the total data. The box, half of it is 25, half 25. So the whole box and whisker plot contains 50% of the data, or half, and then the other whisker contains the other 25% of the data. Okay, since median is half, and the first quartile is cut in half again, and the third quartile cuts it in half again. All right, so we're going to look at some examples here today. This is a double box and whisker plot, and we're asked to, part A, identify the shape of each distribution. Which test scores are more spread out? Explain. Okay, we're actually going to look at this example here. We'll save the double whisker plot for a moment. Okay, so here is a box and whisker plot. It represents the lengths in seconds of songs played at a rock band at a concert. So part A, find and interpret the range of the data. Part B, describe the distribution of the data. Part C, find and interpret the interquartile range of the data. And D, are the data more spread out below quartile 1 or above quartile 3? Explain. All right, so part A is talking about the range, which we learned about in section 11.1. The range is when you take the greatest value, which in this case is 300, minus the least value, which is 160. The range, the greatest value minus the least value, which gives us 300 minus 160 is 140. So that's our range, and they also ask us to interpret the range. Explain what it means. Well, this means that the song lengths are not going to vary by more than 140 seconds. So this means that the song lengths will vary by no more than 140 seconds. Okay, that's the largest gap between the largest data point and the smallest. All right, part B, describe the distribution of the data. Now this is where we're going to think about where the majority of the data is located. Remember, inside the box, in between quartile 1 and 3, this is where 50% of the data is located. 25% of the data is located in the first whisker, and then the other 25% of the data is located in the second whisker. Okay, so just looking at this first whisker here, 25% of the data, or 25% of the song lengths, since that's what this particular data is about, is located between 160 and 220. So 25% of the song lengths are between 160 and 220 seconds. All right, now looking at the box. Remember, the box contains 50% of the data. So 50% of the song lengths are between, looks like 220 and 280 seconds. All right, and this last whisker here, again, that tells us 25% of the song lengths are between, this looks like 280 to 300 seconds. All right, and that is how we describe how the data is distributed. You look at the two whiskers, those are both 25%, and then the box is 50%. Okay, part C. Find and interpret the inner quartile range of the data. Now, this is a new term that we haven't seen before. The inner quartile range, which is abbreviated IQR, that is when you take the third quartile number minus the first quartile number. So when you take quartile 3 minus quartile 1. A lot like the range that we found earlier, except we're using the quartiles instead of the least and greatest points to subtract. All right, so when we do that, again, our quartile 3 point is 280 and our quartile 1 point is 220. This will give us our inner quartile range, which is 60. Okay, they also want us to interpret what that means. What we just found is the difference between our third quartile and first quartile. So this means that the middle half of the song lengths vary by no more than 60 seconds. Okay, and part D, are the data more spread out below quartile 1 or above quartile 3? Well, we can clearly see that the left whisker is more spread. So the answer would be the data is more spread out below quartile 1. Okay, because the whisker is definitely more spread in this location than the whisker above quartile 3. All right, now going to this box and whisker plot shape options. So box and whisker plots can have these three basic shapes, and these three terms, skewed left, symmetric, and skewed right, describe how a box and whisker plot is distributed. So the key in telling which vocab word to use here is to look at the whiskers. You can clearly see here how the left whisker is far more spread out than the right whisker. When you see something like that, you would use the vocabulary skewed left. The left whisker is longer than the right whisker. Most of the data are on the right side of the plot. Okay, and then symmetric. Here's the median here, and notice on the left side and right side of the median, it's nearly a mirror image. When that happens, you would label your box and whisker plot as symmetric. Okay, and then skewed right is when you're looking at the whiskers and clearly the right whisker is far more spread than the left whisker, you would use the vocabulary skewed right. All right, so going to this double box and whisker plot. Part A, identify the shape of each distribution. So looking at your friend's class in blue, I can see that the left whisker is far more spread than the right whisker. So for part A, when I'm describing the shape, I would say the distribution for your class is skewed left. Skewed with a K. Skewed left. Okay, because the left whisker is clearly far more spread out. And if we're looking at your friend's class, this is the red box and whisker plot down here. This looks to me symmetric because the left and right side of the median are like mirror images of each other. So you would say the distribution for your friend's class is symmetric. Okay, part B. Which test scores are more spread out? Explain. When you're talking about spread, you want to look at the range, both the range and interquartile range, which I just should abbreviate IQR since I'm having trouble spelling. IQR are what you want to look at to see spread. So looking at the top blue box and whisker, we see that the range is, this looks like about 68, anywhere from 68% to 100%. Whereas your friend's class is far more spread, anywhere from 60% to 100% is the range of the scores. Looking at interquartile range, we'll see the same thing. For the blue, your class, the interquartile range is anywhere from 85 to 95, whereas your friend's class, the interquartile range is anywhere from 70 to 90, far more spread. So because both the range and interquartile range on your friend's class are more spread than your class, your answer would be your friend's. The tests in your friend's class are more spread out. Okay, and those are the basic 3 examples I wanted to go through today.